What can I do, algebra-wise? Well, how about multiplying both sides by this denominator? What would happen if I multiply both sides by this quantity? What do I then get? Go back here. In other words, if I multiply both sides by this, I multiply over here, I still get 0. Because in a fraction, think about it, in a fraction, which part of the fraction can give you a 0 value fraction? The numerator or the denominator? Only the numerator. With the denominator 0, what happens, Ann? If you got a 0 denominator, it's undefined, yeah. So the only thing that can give you a 0 fraction value on a fraction is the numerator, and if you multiply both sides by this, it proves it. It goes away, it's 0. Okay, so I've got 2x, that's a parenthesis, minus y plus, actually, can I collect some terms here? Yes, let's do that. Let's see, what is that, 3x? Oops, the y's cancel, don't they? So I have 3x dy dx plus, actually, minus, right? 3y is equal to 0. I bet you can see it now, can't you? How we're going to do that? Dy dx is going to be 3y divided by 3x, or simply y divided by x. Now, this is a derivative, just like it always has been. What does that tell us? I'm a little leery of calling them functions always. Let's just say equation. This equation will give the slope. Slope of what? What kind of a line? Tangent where? To a curve, but what curve? Yeah, tangent to the curve, but it's going to give us a curve to the curve, and it's going to give us this one. If I could graph it, if I could use the, which is going to be impossible to do with what we've got so far, graph it to the curve, where? Anywhere, at a point, but we're going to have what to know the point now? To know the slope, can I just give you the input value? Or do we need both x and y? Do we need both coordinates? And we do, because this derivative needs both. What happens is these are not functions. I really don't have a graph for this one. I think I could get us a graph for it. I don't think it's that impossible. Let's look at this. If I multiply both sides by that denominator, yeah, I think I could say 2y equals x, or y equals, that's going to be interesting, 1/2 x. Did I do that right? So the graph is actually just a straight line, it looks like. I guess I never took time to do that. I have to go back and make sure. But what do you think? Did I do that right? This is interesting. Let's say we want it at the point where x is equal to 3. Then this would be 3/2. That means our derivative would be how much? I'm backing myself into a corner here, class. I don't like this. We're going to ditch that just for a moment. I got to think about that because I don't like what I'm seeing. Let's move on. I'll think about that as we move on because I've got myself into a corner there that I don't like. Okay, let's go on. Implicit differentiation. I need to take the derivative with respect to x of each and every term up here. The first term, I hope, is no problem to you. If it is, you will have difficulty with the quiz today. Minus, this is going to be the product rule we have to use here. This is going to be the chain rule that we use here, equal to 0. And because of the time, we're out of here, well, we got actually a little more time. We'll keep working on this. I'll give you half an hour to get that quiz done. The product rule. First factor times the derivative of the second factor, so the derivative with respect to x of the second factor, plus the second factor, which is y, times the derivative with respect to x of itself, let's just stop right there. We're not done at this point, but we're going to stop, not stop with lecture, but stop with writing at this. Let's see, this is 3x squared. This is x. What is the derivative of y with respect to x? dy dx, okay. Plus y times, what's the derivative of x with respect to itself? 1. I'll put a 1 there for those who need it. Okay. Plus, now let's work on this one. This is a squared, not a 3. Okay, so we did this before, right? So this would be 2y times the inside function. So this is the outside is squaring, so we have 2 times y. And then we take the derivative of the inside function. So we'd have 2y dy dx is equal to 0. We have to see the composite function. We've got to think it just like we were in section 2.5. So let's see, we got 3x squared plus x dy dx. Whoops, I forgot we had a change of sign there, don't we? Did you catch that? We got a subtraction outside that whole thing. So minus x dy dx minus y plus 2y dy dx. What are we going for? dy dx. Okay, can we now solve for dy dx? I've got 2 terms with it. So if I bring those together and factor out the dy dx, I would have negative x plus 2y, and take the other terms to the other side, y minus 3x squared. I'm kind of hurrying through this. You have to be sure you go back and look at this video. But all I'm doing is, I'll go back and do one more run through of this. I'm just taking each of these as, this is a product, so I have the first times the derivative of the second and second times derivative of the first, and evaluating if it doesn't have the same letter, if it doesn't have the same input, then it's its own function. So it's dy dx. Okay, so dy dx equals y minus 3x squared divided by negative x plus 2y. I'd have to stop there because I can't cancel unless they're factors, and you know this y is not multiplied to everything up there, so I can't cancel anything. This again, this is a derivative equation, but I can't find the slope of the derivative. I can't find this, I said that wrong. Can't find the slope of the line tangent to the curve unless I know both x and y in here. Okay, I think we will stop at this point. We'll pick this back up and see how we can apply this.